Section 7.4 is titled Percents and Interest. This is really like two sections mushed into one that are kind of not exactly lending themselves into the same section. They've just put them both in the same section. So we're going to start with percents. The word percent comes from the Latin word meaning per hundred, as in our word cent. Cent in our vocabulary, a penny, a cent, is 1/100th of a dollar. So when we see n%, we mean n per 100. The first thing we're going to work on is converting between percentages and numbers. And there's several ways. I know that you probably have seen some of these before, but depending on what resources you might have when you're working out in the field actually teaching kids, you might see some more of these. So I want you to be aware that other methods exist. Okay? So the first one is that you write the number as a fraction with a denominator of 100. Okay? So if you have 7.9, you write that numerator as something over the number 100. So what you actually see happening is you see the 7.9 written as over 1, and you want it to be over 100. So how do you get it to be over 100? Well, you multiply the numerator also by 100. So you get 790 over 100, and that's actually why we call it 790%. You get 790 per 100. The second way is to use proportions. Proportions work very nicely when you're dealing with a fraction into percent. I'm using 7.9 in all my examples, but if you had the number 7.9 over 1 and you did it in proportion form, you can set that equal to n over 100, and then you can cross multiply. So this is n equals, and then you have 7.9 times 100, which would end up giving you 790%. And then the third method is probably the one that you're most familiar with, and it has to do with simply moving decimal point. Okay? So when you're dealing with a number like 7.9 and you're wanting to turn it into a percentage, especially if it's not a fractional form, it's actually a decimal to start with, one option is to move the decimal point 2 to the right. So 7.9, and then we move the decimal point 1, 2, 790. So I didn't need my last 0 there. So we're going to do a couple examples. I think you guys know enough about doing this to do part A at least. You might get a little stuck if you think about part B, but we'll do it together if that happens. So give part A and part B here a try. Once you've tried it, look at your neighbor and say, did you get this? Compare your answers, okay? It's what it, oh, that's okay. The numerator can be bigger than 100. It's the denominator that needs to be equal to 100. Yeah, the numerator definitely can be bigger than 100. In fact, it was in the example I did over here. Right.
I guess it's just a lot bigger.
It's okay. It can be a lot bigger. That can happen. What did you guys get on part A? 4,260%. It's very big. Is that the one you were talking about?
Yeah.
Madison, yeah. So, one option, of course, is to simply move the decimal place. But the reason that moving the decimal place works is because if you were trying to multiply to get a 100 in the denominator, and you multiply the numerator by 100, that would move the decimal point 2 places. Okay. Part B is a really good example of the proportional one working well for you. So did anybody try it with proportions on this one? Yeah? Okay, good. So I would be tempted to do that as well because of the format of it already, is to write it as n over 100 and then to do cross multiplication. So I have 800 equals 3n. And then I know you get a repeating value, but what is the value that you get? 266, and then what? 0.6 repeating. That's fine. And this is percent as well. Did I write percent on the other one? Yes. Okay. All right, so that's one direction. We're going to go the other direction now. We're going to take a number and to turn it into a percent, and there's two methods for that. The first one is to divide by the number 100. And the second one is to move the decimal point 2 places to the left. And of course, these are the same method, really, right? They end up with the same answer. So let's take an example for this one. I think part A looks a little confusing, and I put it on here on purpose because I don't want you to get confused if you see something like this, because it's got a fraction inside of the percent. It'd probably be easier first to change that to something else. What would it be easier to view this as?
4.5.
Yeah, so I would suggest doing that if you encounter a problem like this. Start with this. All right, so to turn this into a decimal, we will use the number, and I'll use method number 1 because it's probably the one that you're maybe least comfortable with or whatever. The whole idea is to take this number and to divide it by 100. So if you were to take your calculator, you were to write this out by hand, whatever, and you move this decimal point, what would you get? Yeah, 0 point and then 0.45. And the same thing happens down here. If we were to write this out of 100, it would look like this. And if we do that, or we move the decimal point 2 to the left, what do we get? 1.25. Yeah.
So we're always moving it to the left?
We're always moving it to the left when we're turning it from percent into a decimal value, yes. When we go from a decimal value into a percent, we move it to the right. And it all has to do with whether we're multiplying or dividing by 100.
So when we're doing like percent into a decimal, that's what it means, like percent into a number?
Mm-hmm.
Okay, just
Yeah, that's right. I put number on there, Hannah, because the number doesn't always end up having a decimal point. It depends on what the numbers are you start with.
Okay.
That's why. All right. There are 3 application forms that percents can take on. The first one is finding a percent of a number. The second one, finding a percent one number is of another number. And the third one is finding a number when a percent of that number is known. And they sound sort of like, didn't I just say the same thing 3 times or something? I mean, it just sounds like I'm talking through. But you'll see the numbers and you'll see what I mean. So let me give you an example of each of them. So the first one, finding a percent of the number. It would look something like this. For some reason, you need to find out what is 15% of 32. And you probably use some version of this quite regularly when you do certain things. What do you use this kind of a version, or where do you see this kind of a version of a question asked? Sales. Yeah, that happens. Where else? You do it every time. You don't think about this, but you do it every time you pay tithe at church. 10% of your income, right? And I don't know, maybe you guys are all lucky and all the boys take you guys out to eat and you don't pay tips, but tips are use this as well. Whether they use, not necessarily 15% as the number, but whatever it is, you're finding the percentage of that number, right? That's what a tip does. Okay, so this is where this one is used. Let's take another one. So the second one, finding a percent of one number when another number, finding a percent one number is of another number. Something like this. What percent of 47 is 12? Can you think of scenarios when you've had to do something like this? What percentage one number is of another number? Someday you will do this, most of you, because you will want to know what percentage of your class got A's on the test. Now, I'm pretty sure that probably most of you do this with your own grades on a regular basis as well. You want to know what percentage you got right on the test, right? And if the test doesn't have 100 points, like mine, they never do, You have to do this, don't you? It's exactly what you do. Every time I hand you back a test and I tell you how to calculate something, we're doing this. We're finding the percent of the points you got versus, or can get, versus the percentage of the points that are actually awarded on the test. All right, the third one. Finding a number when a percent of that number is known. Something like this. Oops. Move it down here. 13 is 45% of what number? Any ideas on this one?
Like how many total of something you have.
You could, like how many you started with of something, absolutely. So if you were working with like a bake sale or something like that, where you're wanting to know how many cookies you began with when you have a certain percentage of them and you're done with them at the end. Yep. What else? That's where I usually think of too, yeah. So this is the argument that you go home and tell your parents or your boyfriend or your husband or whatever, and you tell them you got such a great deal. This is a great deal. It was originally priced, whatever, right? It makes us feel a little bit better about our purchases when we figure out how much we actually saved. It doesn't matter what we spent, it's how much we saved, right? Yeah. Okay, so what we're going to do is we're going to do 3 examples. There's one of each type. We're going to see how we go about solving that problem, okay? And we're going to do them with proportions, okay? Everything is with proportions. You remember 6.4? And I told you 6.4, everything we're doing is with proportions. Everything in 7.4 is also with proportions, okay? And you're going to love it because it works out so nice when you're doing that with percentages. So let's take a look. All right, so here's our first example. It wants to know what is the sale price of a softball if the regular price is $6.80 and there is a 25% discount. So the first thing we're going to do in all of these problems is we're going to set up a proportion. And the cool thing with proportions and percentages is one of the proportions is always something over 100. So you automatically can start setting the problem up like this every time. Now, either they give you a percent or you're asked for a percent, but this is the number that will go above the other value. Or you'll use it to find the value above there as well. So I'm going to put 25 in here, and we're going to talk about that in a minute. Okay. All right, so what goes on bottom of the fraction that we still have to fill in is original value of things. Okay, so that's the 680. And the part that's on top would be having to do with the savings value or something like this, the new price, these sorts of things. So I'm going to put a letter. What letter do you want to use? B. Wow, wasn't expecting that. Let's go with B today. And we're going to solve this with cross multiplication, right? Yeah. Okay, so you're welcome to grab your calculator as you multiply these. I don't have a problem with that at all. So we're doing 100 times B, or 100B equals, so what's 25 times 680?
170.
What was it?
170.
170?
Yeah.
Okay, great. And then what? Divide by 100. And so B equals 170. Now we need to be careful what the question was that we were actually asked. What were we asked to find? The sale price. What have we found so far? Yeah, we found the discount, right? So if we go through the process like this and we ask that question to ourselves in the end, we can simply subtract. So my sale price is 680, wasn't it? 680? Minus 170 for a total of what? 510. And please make sure you put your dollar sign on there and so forth, okay? Now, there's something else we could have done to avoid the subtraction at the end. Any idea what we could have done?
You could have put different or
No? Yes. When we originally set up the problem, we could have set up the problem so that it was actually a 75 in the problem instead of the 25. Okay, so Abby, you're the one I heard say 75. So why 75? Where'd that come from?
Because it's the remainder, I guess, out of 100.
Yeah.
Just subtract the 25.
Yeah, so like if they saved 25%, then they paid 75%, right?
Yeah.
So if you're actually trying to find out how much did they pay, we could talk about, well, what percentage did they pay? And then if we do the problem from this standpoint, there's no subtraction to do at the end. It doesn't matter which way you do it, not at all, okay? But there are two different options. I would hate for you to look at somebody else's paper and think you simply did it wrong because you did it differently, okay? All right, the question wants to know, what type of problem was this? Number 1, number 2, or number 3? I've heard all 3 options now. Woo! All right, so let's take a look. We are given a percentage, which means it is not 2, right? Because number 2, it says we find a percent. So it's not number 2. Number 1 says we find out what percent something is of something else. And number 3 says that we find out what value we had originally. 13 is 45% of what original number. So this one is 1. It's 1. We know the original price. We know the original amount. We're trying to find the sale amount, the savings amount. This is the number 1 one. Okay, we got a couple more though. A ski area. I'm ready to go skiing. We're going on spring break. A ski area reports that 80% of its runs are open. If there are 60 runs open, how many runs are at the ski area? So, how do we start the problem?
You know the percent.
A proportion that includes the percent, and we have the 100 in the denominator. And I don't care if it's on the left or the right, that doesn't make any difference. All right, what else am I going to put in automatically from this?
60 runs.
60 runs are open. Where's the 60 going to go? Ooh, top, bottom. Which one is it? Okay, it's on the top because it's not 60. 60 is not corresponding to the 100% of the runs, right? I don't know how many runs there are. I just know how many are open. So that the amount that I don't know of what there are is exactly what I'm looking to find. So I'll call that X this time. What's going to go above my 100?
Well, you can do 20 if you want to make it easier.
This one's actually,
Because it's not like
It doesn't correlate.
this one's 80. Okay, Danielle, I felt like you were going to tell me why. Do you know why it's 80 versus 20?
Because we want to find total, not like backwards like we did the first one.
We do want to find the total, so that's why my 60 is on top versus being on bottom. Why? Can anybody tell me why? I mean, the last time we talked about whether we should put in the 25 or the 75. This time it's flat out 80. We don't want to put in 20. Yeah.
Not 20 of the runs aren't open. 80% of the runs are open.
Right. We want to make sure that we're comparing the same thing. The language of the problem kind of gives us those clues. So this one says that there are 60 open, and 60 is 80% of them. So the 60 and the 80% correspond to one another. Okay? So it is going to be an 80 in the problem on that one instead of a 20. And then we're going to cross multiply. So we have 80x equals 6,000. We'll divide by 80. 75. There are 75 runs. And as we think about that right there, we need to make sure we put the language that goes with it on there. The word runs, okay? The dollar sign, the units, whatever the situation is. Which type of problem is it? 1, 2, or 3? It's 3. 3 is finding the original full amount of something. And that's what we found. We found 75 runs at the ski resort. All right, example 5. Mort. I feel like I left something out. Oh, no, I didn't. I'm right. I'm sorry. Mort bought his house. I was expecting something different. In 2008 for $159,000. It was recently appraised for $195,000. What is the approximate percent of increase in the value of his house to the nearest percent? Okay, we're doing proportions. I think that's about the 4th time I've said it, or maybe the 10th, I'm not sure. But every time we're going to be doing proportions, right? I know there are other ways to do these problems. The proportions is what the focus is in this section, okay? And we know that one side of it's going to have a 100 in the denominator. And this problem is actually asking us to find what the percentage is of something. So that's my value that I don't know. You have to be careful. Some of you are probably already putting numbers in, and I want you to pause for a second just to ask yourself, you may have done it right, but to ask yourself if you've put the right numbers in, and if so, in the right place. So let's be very careful of what it's asking us to find. It's asking us to find the percent of increase.
So you wanna subtract
Say that louder.
you wanna subtract like 159,000 from 195.
Right. What we want to know is how much the value of the house went up, right? Again, if we don't do the problem from the outset this way, it's okay. It just means that in the end we have to remember to fix our answer to actually make sense of the problem. If we can be careful at the beginning, then we don't have to remember it at the end. I'm kind of a fan of that because once I get to the end of the problem, or what I perceive to be the end of the problem, I'm just ready to move on. And I might not remember that I wasn't really finding the right thing. So this says percent of increase. How much did the house price increase? 36,000. So we're going to put the 36,000 on top because that's the percent that I'm looking for. What is 36,000's percentage value? Now I got to decide what goes on bottom. The original price. Very good. See, the original price was my $159,000. And now you really hope you have a calculator because you're not going to do this one in your head. I have 159,000 times X equals, and this actually gives me 3,600,000 on the other side. And we would divide by the 159,000. Okay, it wants the percentage to the nearest whole percent. So we're just looking for a whole number. We're going to round whatever we need to a whole number. So what do we get on this? What was it?
0.64, but you would do 23.
So it'd be 23. That's what I think it should be. Check on your division, Madison, just double check that. You should be getting 23% after you round. Did you find your error? Okay. Let me pause for a moment. You don't necessarily need to write this down, but I do want you to be aware of how the problem would look differently if you had sort of not been aware of this percent increase business at the beginning and you had proceeded down a slightly different path. So if you had decided new price is the 195,000 and you had done that value over 159,000, is equal to X over 100. And you'd had your 159,000 X, of course. And this would have given you 19,500,000. Tell me what happens when you divide this one. What is it?
You're not going to get like a decimal or percent.
True. What do you get? Did you get a value, Abby?
I didn't check, but I just figured.
I got 122.6 over 23.
123%. So let's make sense of what we found. What is 123%? Okay. But what is it in terms of the problem, I mean?
100 plus the 23%.
You have the 100% price, the original price of the house, plus the 23% increase. Do you guys see that? So can you find out the answer from this at the end if you decided to go from this perspective? Of course you can. You just have to remember to subtract off the original 100% of the price of the house, and you'd have your 23% left over. Okay? What type of problem is this? 2. I am finding a percentage, and that is the only thing that number 2 does, is find percentages. All right, we're going to look a little bit at mental math. Here's the catch on mental math. I can't see inside your brain. Sometimes it'd be nice, maybe, Maybe not. Maybe I wouldn't want to see into your brain. Maybe I'd be scared by what I saw. Not sure. Anyway, so here's what's going to happen when you do mental math. You have to write down a little bit of what's going on inside your brain so I know how you're thinking about it, okay? Because there's usually more than one way to think about the problems when you're doing mental math. So 15%. Any thoughts about how you could do that without taking your calculator out and multiplying by 0.15? That's not mental math, okay?
I think of it as like doing it by 10 first, because I just have to do like 10% is easier for me to figure out. So like 10% of 42 is going to be about 4 point. Oh gosh. Let me think.
Jump and helper. What do you guys think? Maybe 420.
420.
Yeah, 10% is a really nice value because it's just moving in decimal point, right? So when we take 42 and we move the decimal point 1, we get 4.2. And then how could I use that information to find 5%? Yes. It would be halving this. Let me write it here. And then what do you do with the 4.2 and the 2.1? Yeah, you add them together to give you 6.3. This one was dollars, wasn't it? Yeah, so we'll put a dollar sign with it and make it $6.30. Okay. Now, I will tell you that if the book doesn't ask, and they don't always ask for you to explain your math behind it or whatever, but on a test, if I ask for something about mental math, I'm going to expect to see you write out words about what you've done. And I didn't even write a lot of words on this screen, but I would expect more words from you. Okay? I would expect you to say something like what Hannah was saying when she first broke it apart and say, I break apart 15% into 10% and 5%. I can get 10% because I move the decimal one over. I get 5% because I divide by 2, and then I add the values together. All those words would go on the paper. Make sense? Okay. What about B? 2 10%. So what you could find 10% and then do what with it, Catherine?
And then, double it.
Double it. So you could find 10% and add it to itself, or find 10% and multiply by 2, right? So 10% doubled. So what is 10% of 280? 28. And then when we double it, what do we get? 56.
Wait, how do you know that 10% of that is $20?
How do we know that 10% of 280 is $28?
Move the decimal forward one time.
Yeah. 10% is like our all-time favorite percentage ever because all it does is move a decimal point one place to the left. Yeah. So if we're right here, which we would move it 1 to the left, we'd be at 280. If we're right here, we move it 1 to the left, we'd be at 420. $4.20. What would you do to find 5%? Yeah. So it would be a lot like step 1 or part A of this problem, right? You just wouldn't have the additional pieces afterwards. So you would take 10% and half it. So what's 10%? Yeah, 320, 3.2. And then half that. And you'd be at 160, yeah, or 1.6 if you didn't have the symbols, yep. Okay, there's a couple of distinctly different options, like very, very distinctly different on how to do part D. So give me an example.
Like we've been doing.
We can do what we were doing.
10%, 5%.
10, 10, 5. Could we do that? Yeah, we could do that. What's another option? I'm not going to do it that way because I know you guys are sort of thinking in that mind. What do you think, Abby?
Find 50% and then divide it by 2.
You could. You could find 50% and divide it by 2. You could half it twice. What else could you do?
Divide by 4.
You could just divide by 4. Yeah. dividing by 2 twice, or dividing by 4. Because that's what 25% is. It's 1/4 or 1/4 of the original value. So especially if it's a value that's even, it works very nicely to do this as dividing by 2 twice or dividing by 4. So we could, on this, divide by 4. And I recognize that the other methods we said are perfectly legit too. I'm not saying this is the best way or anything like that. It's just a different one that I've shown you. So this would give you 21, right? Any questions on that one? Okay. Conceptual question. Why is it possible to have an increase of 150% in price, but not a decrease of 150% in price? If we decreased it, we'd end up with a negative. Okay, so that answers part of it. That's the why it can't be decreased by 150%. We'd end up with a negative value. Okay, I'm not going to write. I'm just going to let you guys write it in your own words. That's the decreasing issue. We'd have a negative value if we decreased. Because what's the most we could decrease something? 100. We could decrease something 100%. It just means we give it away for free, right? But anything over 100, we can't, or at least it doesn't make sense to, because we would actually be giving somebody something and paying them to take it. Right? We don't do that, especially if you think retail kind of things like the store. And they don't do that. Why or what does it look like to increase something by 150%? Okay, so one way to do it, like in terms of mathematically doing it, is to multiply whatever it was by 1.5, but that won't actually increase it by 150%. You have to do something else too. Yeah, so you guys have both said two different things that are very similar. So one way to do something, if you increased something 100% in price, you'd actually end up multiplying it by 2, right? You double what the price was. So if you want to increase it by 150%, you'd have to double it and then add 50% more. Or like Madison actually, her words had said, you could multiply it by 1.5, but then you'd have to add that to the original price. Because that's just the increase amount, the 150%, the multiplying by 1.5, but it's an increase on top of the 100% you already had. Okay? So let's just talk conceptually. So that's very mathematical, like how do we do it kind of thing. What is it that allows us to do that, but not the decrease?
It doesn't leave you with a negative amount.
Yeah. Why doesn't it leave me with a negative amount, Taylor? Do you know?
You're doubling the price and adding on to plus that.
It's addition, right? Yeah. The increase in this is an addition fact, not a subtraction fact. So that's the difference. I can actually add as much as I want to in terms of a percentage. But if I actually need a percentage to say positive, I can't subtract indefinitely, right? I have a cap on how much I can subtract off of something. Good job. Very good. All right, that's the end of what's called percent in this section. So the other section, part of this section is called interest. You guys ready to get it started? We won't finish it today, but we are going to get it started. Y'all ready? Okay. Terminology first. Interest. Interest is the amount of money you pay or earn to borrow or lend money. Interest. It's not a rate, it's the amount of money. Okay, so when I say interest, it's actually a cost value of something. You guys have seen this before with your bank accounts, I suspect, or a credit card. Okay, it's the amount then put on the end of the credit card if you maintained a balance from the month before. It's the amount that if you're looking at your bank account and you have something that pays you interest, like a savings account or a checking account or a CD or something, it says plus, 42 cents at the end of the month or something like that. That's interest amount. The principal is the original amount that you used to determine the interest. So it's the original amount that you borrowed or that you lent. Okay, so technically when you put your money in the bank, you're lending them your money. Okay, you're putting it on deposit with them. That's like a lend. Sounds weird to say it that way, but you really are. You're lending them your money. The interest rate is the percent that's used to determine the interest amount. So you'll see people talk about all the time on television, you're like, 2.9% APR financing over 60 months or something like that, whatever they say, right? That's the percent, 2.9%. That's how they use it to determine how much interest you'll actually pay. There are two ways to calculate interest that we're going to explore anyway. One is simple interest. Simple interest formula right there. And then the other is the compound interest formula. So now we need to write out to the side what all those letters mean. So let's see if you guys remember them. Do you remember what P means? Principal. So P is the principal. It's the amount of money you put in the bank. It's the amount of money that you borrow from the bank. What would R be? It's the rate, and you need to make sure you write down as a decimal. Okay? It's not the rate as a percentage. So if it's 5%, you got to turn it into a decimal first. T. Time in years. Always in years. So if the problem gives you something about an 18-month loan, you got to stop and don't put 18 in there. You got to figure out how much of a year 18 months is. Okay? Because car loans are done like that a lot. It's for 60 months. Right? For 72 months, for 36 months. Always written in months, but the process for calculating it is in years. All right, I think I need one more. Oh, well, I haven't said what A is, I guess. A. A is the amount at the end of whatever's happening. The amount at the end of the month, the amount at the end of the loan, the amount you have paid over the course of the whole thing, whatever. It's the final amount of something at some point in time. The last letter I have not done is N. Does anybody remember what N is? It's only in one of the formulas. Okay. There you go. Good remembrance. Yes, it is the number of times it's compounded. So if the loan or the account you have compounds monthly, how many times would that be in the course of a year? 12. So you'd put 12 in for N. If it compounds annually, that would be 1 time a year. Quarterly would be 4 times a year. Sometimes you'll hear the words daily, and we'll use 365. Don't worry about the leap year business. It's just not enough of a difference to make any difference. It just isn't. What if it were weekly? 52. Good job. All right, so we're going to look at those. I do have a note on here. The formula that I'm going to be giving you, the formula that I gave you for compound interest, is not the same formula your book uses. But the one that I gave you is the one that most books use. So it's the one that I want us to focus on, okay? So there's a very simple reason why, if you look at the book and you can compare them and see them, but just be aware if it looks different. I'm aware of it, and it's okay. This one will work just fine. All right, so we're going to do an example. A company is expanding its line to include more products. To do so, it borrows $320,000 at 13.5% annual simple interest. Your problems will always tell you what kind of interest it is. Okay? Don't overcomplicate this. Please don't. If it says simple, please use a simple interest formula. If it says compounded monthly, compounded something, if the word compounded is in there, use the compound interest formula. Okay? Look for the word. It's there. Simple interest for a period of 18 months. How much interest will the company be charged? What if they are charged 13.5% compounded monthly? So it's a separate question, okay? So the first thing we're going to start out with is the right formula. What is the formula that we want to use for finding this kind of interest? Simple interest. And I gave you 2 versions of the simple interest formula. The only difference between them is the P is distributed in the right one and it's not distributed in the left one. I don't care which one you use. It makes 0 difference, really. So just pick whichever one you want. I'm going to use the first one. So actually I'll use the second one because then I only have to write the 320,000 out once. So this is P times 1 plus RT. And we said P is 320,000. It's how much they borrow, right? One plus. What is R? Close. All right, 0.135. So, Catherine, where did you get 0.135? Yeah. So we need to take 13.5 and divide by 100, or we need to take 13.5 and we need to move the decimal point 2 to the left. It's 0.135. Time, T, what is it?
You have to find out what 18 months is.
We have to figure out what 18 months is of a year. How much is it?
1.5.
It's 1.5 years. Time is always in years for these formulas to work the way they're set up. Okay, grab a calculator. Some of your calculators may make you work from the inside out. You may need to type in 0.135 times 1.5, hit enter, plus 1, hit enter, and then times 320. Some of them may allow you to do it like this with the parentheses as I've shown them. So be careful. How much do we get from this?
384,800.
Now there's a catch here. What did I just find? The total final amount that they have to pay back. Is that what I was asked to find? I was asked to find the interest. So how am I going to find the interest?
Subtract what we put there originally.
I'm going to take my 384. Y'all are all saying it. And I'm going to subtract the original amount, which was 320,000. And you don't necessarily have to show this step, but I want it to be very clear to everyone where it's coming from in case you didn't see it initially. What would we get? $64,800. A lot of money, huh? Because of the way this problem is created, if we had used this other formula over here, this is the principal, this right here is the interest, PRT. So you could find this question's answer directly by just finding what is P times R times T. The reason I don't usually show it that way is because if you were using the compound interest formula, there is no way to do that. You actually have to do exactly what I did. Find the total amount, subtract the original amount. Okay? So I kind of think about it in that same way for this version of it. Now, the second question said, what if they are charged this 13.5%, but it's monthly instead of a simple interest, right? So if it says it's compounded monthly, it means I need to use the compound interest formula, right? There's a key word in there. Be careful for it. So compounded monthly means that I'm using the one that says A equals P times 1 plus R over N to the NT. What's P again? The principal, $320,000, right? 1 plus, my interest rate, we already did that a moment ago, was 0.135. What is N in this problem? 12, because it said compounded monthly, right? 12. And this is raised to what power? 12 times 1.5, right. Okay. Here's where you have to be careful. And here's why your book does what they do, actually, a little bit as well. If you enter this into your calculator exactly like the parentheses that I have shown, your calculator will probably give you the wrong value. And the reason that it will is because it will raise it to the power of 12. And it will take that value and multiply that value times 1.5. But we really want the 12 and the 1.5 multiplied together in the exponent, right? Yes. So I would suggest whenever you're dealing with these problems to simplify the exponent before you do anything in your calculator. That's all it takes. Just take your exponent, figure out what it is, and then your calculator will tolerate the rest exactly as it is just fine. And that exponent is 18. Any idea why that exponent 18 might be 18 based on this particular problem? It's for 18 months and it's compounded monthly, which means there's 18 payments. 18 times that the interest compounds. Okay? So, go ahead and grab your calculator. Find out for me, what do you get on this problem? I don't have the answer to this one written down, so I hope you guys have it. It's 300 something, I'm pretty sure. What'd you get, Madison?
I got 320,000, but I think that's.
Yeah, that's not right, because it needs to be bigger than that, right?
391,384.
Caitlin, you're shaking your head. Is that what you got? Okay, 391,000. What's next?
384.
384. Did it have any change, just for the sake of having it? 48. Okay,
More.
48. This again is the amount. It's not the interest, right? So to find the interest, what would I need to do with that value? Sub- subtract the 320,000 from it. What would I get? All right, 71,384.48. If you're having trouble with your calculator giving you that value now that you know what it should be, please let me know so that we can get that error fixed before you start trying to do problems and continue to make the error. Okay?